Welcome to the latest podcast edition of Reimagine Mobility. I'm here with Michal Trcalek. He runs our vehicle group. Michal, tell me a little bit. Vehicles have changed just from a few years ago when EVs were kind of talked on the far horizon. Today we kind of look back on EVs first edition, second editions maybe, and look at the next generations. What has changed?
What has changed? Well, a lot. So the industry steadily evolves. So if we think back to the early 2000s and the Prius came on and the Nissan Leafs, the whole methodology of those vehicles was quite a bit different than what they are today. It was more about getting the product into people's hands. Obviously with the Prius, it was more about maximizing fuel economy. And then the Leaf was like our first vehicle that was fully EV that was available in the marketplace to just about anyone. And, so then we have other car companies like these startups out of California that come up with ways to make the car more exciting, right? That's I think how I think it expanded its customer base, right? They have attracted the clientele, and especially by pushing the advantages of this technology from ecological point of view and environmental point of view. I think it's driven a lot of visibility and just striving to reduce our impact to the world. So I think all that is bringing in this change, and now, in order to get more population introduced into these, we have vehicles that accelerate with ridiculous speed. And
What's it called? Ludicrous, I think, right?
Well, yeah. So it started out with ludicrous, right? Then we went to plaid mode, right? And there's then I think the Sapphire is the top notch.
Oh, I haven't heard of that. Okay.
Yeah, that's I think that's the latest offering from the California startups there. So.
Okay. That's good.
Yeah.
You're making a good point. I think some people sometimes think EVs just kind of came on the scene over the last 4 or 5 years, but been around for a while, right? I mean, the Chevy Bolt's been around, the Volt even longer, now getting a hybrid there, the Prius, obviously. You're bringing up, though, a very good point to startups. And to me, the startups, besides all the technologies they brought to the forefront and maybe challenging some mindset of how you develop vehicles. But I really also feel they kind of rejuvenated an industry that maybe felt this is the way to go. And with the startups bringing a different mindset, methodology, process in it, kind of challenging the status quo. And I think we see some changes now by traditional OEMs as well. So Can you shed a little bit of light from your perspective, what you have seen working with all these different OEMs and different type of vehicle programs that we've had over the years?
Yeah, so, within the vehicle group, we have a lot of benchmarking activities that we do. So we get a lot of visibility to all of the new upcoming technologies that are emerging on the market. And so what we see a lot from especially less established OEMs or manufacturers, we see a higher level of integration. So a holistic approach to vehicle thinking, right? So it's not an engine and transmission and a number of components pieced together within a vehicle. It's how can we combine these components into a single piece, reduce complexity, reduce weight, maximize efficiency out of the vehicle.
So like a 3-in-1 e-drive for e-axle, for example, would be an example.
Yeah. Okay. So it's whether it's on the electrical side, so you have all of these high voltage components, right? So certain manufacturers take a piecemeal approach where they have one component for one thing and one component for another. Whereas, what we see in the latest trends, latest technologies, that we see multiple components merge into a single one, and therefore they can reduce the mass of the housing. They can shorten the leads of the cables or the bus bars and so forth, leading to weight savings, resistance losses, from the electrical system as well. So just the overall holistic approach in terms of maximizing the potential of everything.
Do you see it as more as the reason or the cost for it because of legacy systems that the OEMs had, that they said, hey, there's always a different type of vehicle that's more technologically advanced. Hey, we grab this from this one and this component from that, bring it over here and make the next, kind of like more of a step by step versus take a major leap and don't take stuff from the old vehicle that maybe the startups are doing? Or is it just a different mindset that they're bringing?
Well, I think it's probably a little bit of both, right? So, certainly evolving a component is much cheaper than starting from scratch, right? But if you have nothing to start from, you just have the freedom to do whatever.
Yeah.
We've seen that especially on communications within the vehicles, right?
Okay.
So most of the vehicles out there in the market today have a CAN communication protocol. However, some of the latest vehicles that are coming out are Ethernet based. You get much faster speed, much more data can transmit, and you also get better security encryption. Now, that for a manufacturer that's used to doing CAN bus would mean that they have to rebuild their complete controls architecture. They'd have to start from scratch. And that could be very costly, very time consuming, and potentially lead to some errors and faults down the line. So that introduces a lot of risk. So if you're starting from scratch, you can start with the latest technology. You can pick the best things you want to do.
Sure.
And sure, it comes at a cost, but you're setting yourself up for the future.
Right. You're talking vehicle communication, you're talking integrated modules. What do you see next happening? I mean, I think the traditional OEMs certainly are looking over their shoulders, right? Or looking at their peers now in some cases, looking at benchmarking that we provide and to try and see what can they learn, right? But I also know the OEMs are not necessarily looking at what somebody else is doing, but realizing, hey, the competition is real. We can't just be constantly on par with the competition. We got to leapfrog the competition, right? This mindset of technology leadership. I need to lead with technology. What do you see next happening?
Well, there's certainly a lot of things going on, right? So there's different battery technologies, different e-motor technologies, all those things. But I think something we shouldn't forget about is just the basics, right? What's going to drive efficiencies and range is mass. How can we reduce mass out of these vehicles, right? So it goes back to materials engineering. It goes back to reducing complexity of components. I think that there is a lot to be had there, right? Aerodynamics are a very large portion, but of course, a lot of the vehicles that are coming out are best in class from the EV standpoint, best in class in drag, and that's great. And we're already pushing in those areas. So what comes next? It's going to be just chipping away at it. The combustion engine has been around since the 1900s, right?
Yeah.
And if you look at the progression of the efficiency of that, it took 100 years to get to where we are today. And we hit a wall, essentially, right? That essentially it's much more difficult to get any better at that. So it's going to be a progression. It's going to be much faster, it seems like, with the tools that we have available today and computational power and so forth. So it's going to evolve more faster, but I think it's going to be just polishing it away.
You talked about material reduction, right? Weight reduction, let's say weight. Do you see is this something that over the years we in the industry haven't really paid too much attention to it and now it becomes a topic? Have we not paid attention to because we didn't have the tools, let's say simulation, to tell us a slightly smaller A or B frame or pillar would still be good enough in a crash? What is it? Or what do you see? Maybe the answer is not, it was this and that is it. But what do you see? What was the reason? Is this...
Well, don't get me wrong. I mean, that optimization has always been ongoing. And I think, it's going to be the same thing for EVs as it is for ICE, right? You take the same penalty for mass. The difference is that because of the vehicle layout, the vehicle can change. It doesn't have to be the same shape that we're used to. We can rethink on how vehicles are structured, and therefore we can probably rethink how the materials are utilized within that vehicle to optimize itself.
Okay.
Right.
Okay.
So, for example, in one of the vehicles out there, there's the Lucid. So it really is quite a bit different than most standard cars today. If you look at how the trunk opens, if you look at how the front end of the vehicle opens, how everything is packaged within the vehicle, there's a different mindset there in terms of a layout. So now you start thinking, well, how are my front frame horns positioned on a vehicle? How is everything laid out? Does that make sense still with the new EV architecture?
Okay.
So I think optimization for the new powertrain is really where the change is going to be.
Do I assume correct with this optimization? Once again, as we've talked oftentimes here on this podcast, simulation plays a big portion again to try and not tell you go in this way or go that way before you use now simulation more than you ever have to make sure you're going into a direction that's not optically making sense or from a high level making sense, but also goes more into the actual science.
Right. I mean, simulation is a great tool, right? You can try out hundreds, thousands of designs before you ever have to, make a piece of metal. And that just cuts down on costs. And we can get into a trial and error situation wherever, which could be much faster than trying to find the best scientific solution.
Maybe changing topics slightly, when your team puts, let's say, prototype vehicles together, right? Either you get a donor vehicle and you put a new propulsion system in it, or you get a donor vehicle and you put a new ADAS level 3 system in it, whatever it might be. What is most of the time the biggest challenge that your team is faced with? Is it the components they don't fit? Is it the communication, as you mentioned before, they don't match up, right? CAN is not CAN is not CAN. What is it that you're faced with?
Well, those are many challenges and really interesting ones. I mean, we often end up with projects that we don't have direct OEM support. So we have to learn the vehicles, right? Learn how they communicate, learn how they operate. That feeds into our safety concepts and risk analysis as well. So we need to understand how the vehicle operates. So it takes some benchmarking, of that specific platform that our customer has chosen to modify.
Or reverse engineering in some cases.
Reverse engineering.
Yeah.
Essentially, understanding everything about how that vehicle behaves, and that can be very challenging. And the controls are a big portion of that, right? And especially with the new systems that have, higher safety encryptions and so forth, it's becoming much more difficult. So that's always a challenge. But that's not to say that's not be overcome, right? Anything can be solved.
That's
right?
The fun of why we're doing it, right? So yeah.
Right. So as engineers, we're problem solvers by default, right? So that's what we do. When it comes to complexity of the systems, getting components lately has been a tremendous difficulty. Just lead times are above normal. Availability is just more challenging at the moment. But from a mechanical integration, it's fairly straightforward. We are able to get much more information on vehicles today than we were in the past, right? So having 3D scans relatively quickly of the vehicle, even if we don't have CAD data from the manufacturer, is much simpler these days.
Okay.
Right?
Is it more dangerous to work on a prototype vehicle that's a high voltage, high power, let's say EV, or something with hydrogen than it is with an ICE vehicle, or is it just different, but it's still quote unquote as dangerous? Or
I mean, in all situations, we're just harnessing the energy, right? So if you take, fuel, gasoline, it's very combustible, very dangerous chemical, right? So you have to take certain precautions, right? Just like that, with high voltage, you have to take certain precautions, right? And at AVL, we have a very good training system. Whenever we work on high voltage systems, we make sure that the people understand what they're doing, that they've been through the training procedures, and we also have key people that can go and check the work. With hydrogen, it's the same steps, same procedure. We need to make sure that there's right people involved, that we understand all the procedures. We have the right sensors for monitoring gas in the atmosphere, in the surrounding area. We need to just have the right tools in place and work with the local officials on getting all that stuff in place.
What do you see happening with vehicles over the next 5 to 10 years? Other than, again, we continue to see more technologies, and we're going to see solid state batteries probably. I can't say sooner than later, but we will see it in the next 5 to 10 years. I'm convinced of that. But what other things do you see with vehicles? You talked about a different design. We're not constrained anymore, maybe to a certain shape or form or whatever. But what else do you see, and what excites you about that? What potentially comes up?
Well, I am a classic car enthusiast, and if you take a look at a progression of, let's say, a sports car from the 70s to a sports car today, they're still very similar. They haven't evolved a ton. Powertrains may have become more sophisticated,
sure,
but are still very similar. So if you take that progression and apply it to the next 50 years, is there going to be a huge change in the way a vehicle looks? I don't expect it to. Maybe some of the frontal area where usually the engine sits gets shrunk. Maybe the back area gets larger. For example, a pickup truck, electric pickup truck. Why does it need a frunk? We could maximize the bed space if we move the cab forward, right? Yeah. You take a hit on crash safety, so potentially, but there's probably ways of solving that problem. So I think the vehicle may evolve a little bit in the way it looks, but I think we're going to strive to optimize efficiency. Combustion engines are going to stick around for the next 5-10 years.
Sure. Yeah.
But I think probably mostly it'll be hybridized. So it's very difficult to predict the future.
Sure, yeah. But what about flying cars?
Flying cars, I don't think that's a good idea.
No, it's not a good idea?
No.
Because there's a Chinese OEM, more or less a startup, right, that heavily is pushing into that. And I've seen a demo, and I see it only online, so it's difficult to say is it actually real, or is it, right? Computer, we talked simulation before, can make it so real that you think this is reality. We're in true reality, or in truth. It's a great graphic, but flying cars.
So
I mean, it's not necessarily a flying car, right? It's more like kind of an eVTOL, so a vehicle, a car that turns into an eVTOL, right? A vertical takeoff and landing type of thing. But what is your take on that?
To me, it becomes, what separates it really from an airplane, right? Today, a pilot of an aircraft has to take many, many hours of training, has to go through a rigorous, licensing approach, right? And it's very expensive, right? In order to drive a car, you have to go to the DMV. You might have to take a class. Now, we have it a little bit easier here in the U.S. than in Europe, but it's much less rigorous than getting a pilot's license, right? So I don't ever see a situation where every household in the U.S. has a flying vehicle. Let's call it that, just from the perspective of people being able to afford it. There's going to be a select few that can probably afford that luxury and explore that, but I just don't see that being a reality. And I think in the 50s they were saying they were going to have flying cars in 30 years, but it hasn't happened yet.
Sure, we're not there yet, no. So maybe last question. There's not a right or a wrong answer, but in your experience dealing with many OEMs, startups and established, from heavy duty to the smallest cars possible, or even maybe two-wheelers, when we talk about electrification or fuel cell-based vehicles, let's just use those two. For those two types of vehicles, what do you see more important? Is it the range on a single charge or fueling, or is it the recharge time or refueling time?
Well, I don't think we can separate the two, right? If we can cut down on the recharge time, then there's no reason to have ridiculous range. Range poses a big battery, right? Even if we go to a solid state, even if we increase, reduce the density and everything, it's just going to mean it's a big battery, right? But if we can maximize recharge, then we can, assuming the infrastructure catches up.
Infrastructure aside, right? Yeah.
Right. Yeah. We could make shorter trips, and if the recharge is down to like 10, 15 minutes, then it seems to be more suitable to take now a road trip. But I don't think we're quite there yet.
Okay.
No.
So independent of whatever recharge or range, the focus from what we've talked just a little bit ago is still on how the OEMs are changing the vehicle. Again, structural, integration, weight, all that stuff. You see that continue no matter what range we're getting and what recharging time we're getting or refueling time we're getting.
Yeah, I mean, I think that's never going to change. I think the problem we always face is that we always strive to get a little bit more. If you look at the entertainment in today's vehicle, it's much more than I had in my '92 Honda Civic.
Or in your classic 1970.
Yeah. So you get a lot more, and all that extra stuff comes with extra weight.
Yeah.
So as long as we keep wanting to have more and more luxuries in our vehicles, we're going to have to try to figure out ways to offset that mass.
And you think it's luxuries? Last question now. Do you think it's luxuries, or it's more we want more and more technologies or gadgets in our cars?
Well, what's the difference?
Well, one is a mindset of the OEM. I want to push more technologies into it. Mm-hmm. On the other one is we make more things that today might be mechanical. We're making more electrically driven, communications driven, just because we can, not necessarily because you want. You kind of made before. My 1970 car is still more or less the same car as today, but engine technology, or I'm gonna, I have an infotainment system now where I didn't have a big touch screen in my 1970.
So just to put it in perspective, right? So let's take the powertrain technology, right? My 1970s Datsun has a 600 pound engine in it. It produced when it was new, roughly 120 horsepower. Now, if you take your all aluminum LS1, from 10 years ago, it weighs less than that, produces 3 times as much horsepower. So the technology has significantly improved in terms of being able to make power out of the same amount of weight, right? But if you look at the vehicle, my vehicle weighs 2,200 pounds. The vehicle that the LS1 comes in probably weighs around 4,000 pounds. So I think it's the luxuries that we're talking about. So the infotainment, the massaging seats, right?
There you go. Yeah.
Lucid Air has massaging seats, and that's really nice. Yes. I have taken some conference calls from the Lucid. But at any rate, do we really need that, right? If we are really striving for efficiency, reducing our consumption, reducing our impact to the world, could we do away with some of these things?
Sure,
and
I get it.
Reduce the weight?
Yeah. But then again, that's right. Technology is somewhat of becoming a major differentiator, and massaging seats is one of them. I mean, I've driven that Lucid, and it's nice. Yeah, it's nice. Thank you, Michael, for your time. Thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.